Not on Europa, not on Enceladus, not on some promising moon orbiting a gas giant where we have been looking for decades. On Pluto, the smallest, coldest, most remote world we have ever classified as part of our solar system. A frozen dwarf planet sitting 5.9 billion kilometers from the Sun, where the surface temperature never rises above minus 220 degrees Celsius, where the atmosphere is so thin it barely registers, where sunlight arrives so weak and diluted that high noon looks darker than Earth's deepest winter night. That Pluto, beneath its frozen surface, locked under kilometers of nitrogen ice, scientists believe there is a liquid ocean of water, and it has been there, stable, unfrozen, for billions of years, in a place where nothing should be liquid, in a place where nothing should be warm, in a place we wrote off as a dead, frozen rock at the edge of everything. And that is not even the terrifying part. The terrifying part is what this means, not just for Pluto, but for every frozen world we have ever dismissed, for every icy moon, every distant dwarf planet, every dark body at the edge of our solar system that we looked at and decided was too cold, too small, too far from the sun to matter. We may have been wrong about all of them. For most of human history, Pluto was a mystery we were comfortable ignoring. Discovered in 1930, tiny, remote, stripped of its planet status in 2006, in one of the most controversial decisions in the history of astronomy, it was reclassified as a dwarf planet and quietly moved to the margins of scientific interest. We had bigger things to worry about: Mars, Jupiter's moons, the search for Earth-like planets around other stars. Pluto was too small, too cold, too far. It would tell us nothing useful. And then, in July 2015, NASA's New Horizons spacecraft arrived. It had been traveling for 9.5 years, 3 billion miles, the fastest spacecraft ever launched at the time, and it still took nearly a decade to reach its destination. When it finally flew past Pluto, the images it sent back stopped scientists cold. Not frozen plains, not a uniform, cratered, dead surface. Mountain ranges, ice peaks 3,000 meters tall, glaciers of nitrogen ice flowing like slow rivers across the terrain. A vast, smooth, heart-shaped plain the size of Texas, later named Tomball Regio, had a surface so geologically fresh it could be no more than a few million years old, on a world that should have been geologically dead for billions of years. Nothing moved on Pluto. Nothing should have moved on Pluto. And yet, the surface was new. Here is the question that kept planetary scientists awake after New Horizons. Where is the heat coming from? Pluto is tiny. It has no significant internal radioactive decay left to generate heat the way Earth does. It receives almost no solar energy. From Pluto's surface, the sun looks like a bright star, nothing more. By every thermal model we have, Pluto's interior should be frozen solid. It has been frozen solid for billions of years, and yet the surface is geologically active, fresh, moving. Something is keeping the interior warm enough to drive geological processes on the surface. The answer scientists keep arriving at, the answer that the data from New Horizons most consistently supports, is an ocean. A subsurface ocean of liquid water sitting between the rocky core and the frozen nitrogen surface, acting as a thermal buffer, keeping the interior warm and driving the geology above it, possibly kilometers deep, possibly global in extent. On Pluto, the evidence is in the terrain itself. Tomball Regio, that vast, smooth, heart-shaped plain, sits in a basin that appears to have been shaped from below, not above. The pattern of surface features around it is consistent with convection cells, the same slow churning motion you see in a pot of water just beginning to boil, driven by heat rising from below, not from above, not from the sun, from inside, from an ocean that should not exist, on a world that should be frozen, at the edge of the solar system where we stopped looking long ago. Put yourself there for a moment. You are standing on the surface of Pluto. The sky above you is black, not dark, black. The sun is a bright point of light, smaller and colder than anything you have ever seen from Earth. There are no colors, no warmth. The ground beneath your boots is nitrogen ice, hard as rock, smooth as glass, stretching to the horizon in every direction. It is the most isolated place a human being could stand in the entire solar system. And beneath your feet, beneath kilometers of ice that have not moved in millions of years, there is an ocean, liquid, dark, pressurized, completely sealed from the universe above it by a shell of frozen nitrogen and water ice so thick that no light has ever penetrated it, no sunlight, no starlight, nothing. Whatever is in that ocean, if anything is in that ocean, has existed in total, permanent, absolute darkness for billions of years. Not the darkness of a cave, not the darkness of the deep ocean on Earth, where at least some faint trace of surface light eventually filters through. Complete darkness, since before complex life existed on Earth, since before the dinosaurs, since before the first fish, since before the first cell divided in the first primordial ocean. If there is life in that water, and we do not know that there is, it has been alone down there, in the dark, for longer than we can meaningfully comprehend. That thought should stay with you. Now step back, because the real shock is not Pluto itself. The real shock is what Pluto implies about every other frozen world we have ever looked at and dismissed. Before New Horizons, the scientific consensus was clear. Liquid water requires proximity to a heat source, a star, or a massive planet generating tidal forces, some external driver of warmth. Without that, water freezes. Simple, non-negotiable. Pluto has none of those things. It is not close to the sun. It has no massive neighbor needing it with tidal forces the way Jupiter does to Io or Saturn does to Enceladus. It is alone, small, and cold, and it appears to have maintained a liquid ocean for billions of years anyway. Which means the rules we use to eliminate candidates for liquid water, for habitability, for life, may be wrong. Not slightly conservative, fundamentally wrong. In our solar system alone, there are hundreds of small, cold, icy bodies in the outer reaches, dwarf planets, trans-Neptunian objects, Kuiper belt bodies. We looked at them and said too cold, too small, too far. No liquid water, no heat, no possibility. If Pluto has an ocean, how many of them do too? And beyond our solar system, in the frozen dark between stars, around dim red dwarf stars, in regions of the galaxy we classified as too hostile for water. How many oceans are sitting silently under kilometers of ice, in the dark, waiting? We have been searching for life in the warm, bright, comfortable places. Pluto just told us we have been looking in the wrong direction. Here is what nobody can tell you. We do not know what is in that ocean. We have one flyby, less than 1 day of close observation. New Horizons was moving too fast to slow down, too fast to orbit, too fast to do anything except point its instruments at Pluto for a few hours and keep going. That data, collected in a single day after a 9.5-year journey, is everything we have. We have no orbiter at Pluto, no lander, no probe that has entered its atmosphere, no instrument that has touched its surface. We have images and measurements from a spacecraft that passed by once and never came back. And based on that single pass, scientists believe there is a global liquid ocean beneath the surface. An ocean we cannot reach, cannot sample, cannot study directly. An ocean that, if it exists, has been isolated from the rest of the universe for billions of years under conditions we have never been able to test, on a world so remote that the fastest spacecraft ever built took nearly a decade to reach it. A follow-up mission to Pluto, an orbiter, something that could actually study the surface over time, has been proposed. Scientists have argued for it. Papers have been written. It has not been approved. So for now, that ocean, if it is there, sits in the dark, undisturbed, unexamined, unknown. And we have no idea what is waiting inside it. We stripped Pluto of its planet status in 2006. We decided it was too small, too insignificant, too far away to deserve the same classification as the 8 worlds we had already named and studied and mapped. We moved on, and while we were looking elsewhere, at Mars, at Europa, at the planets orbiting distant stars, Pluto sat at the edge of the solar system, 5 billion kilometers away, in the dark and the cold, with an ocean beneath its surface. That has been there the whole time. We do not know how deep it is. We do not know how warm it is. We do not know what chemistry is happening inside it, or whether that chemistry has had 4 billion years to do something we have never seen anywhere else in the universe. We looked at Pluto once, for less than 1 day, and walked away thinking we understood it. We do not understand it. We never did.